surgery, and we're in the NXT software, and we've already written the program, and we're going to go over the various coding and additions that we did to this program. So first we start with a motor movement, and we just have half a rotation with the power of 50, and you can see here that we got this motor turning in a forward direction, followed by just a forward movement. And what this does is approaching the control pupil, and what we've added here is a touch sensor, so as it approaches the pupil it won't collect the information until we press the touch sensor located on the side of the robot. And once we initiate that by pressing, as you can see, you change your action to a release or a bump, and we're connected to port 1. We press it, and that will be followed by a sound cue. The sound cue says record. This is to indicate that we're going to record the initial light of the basically black pupil of a normal eye, and we're kind of setting a control value for our intensity. So we click over to our light sensor, and we drop down here, and we can see the different ports that the light sensor has. And what we want to do is grab the value coming out of the intensity port. That value is going to be between 1 and 100. This is basically a scaled value. There's also a raw value, which is a much wider range, and you can always go down to the help menu located in the bottom right to find that information. So we have the robot drive up to the first pupil, which is our control, determines what's the intensity level out of a normal eye. And what we're going to do is take that information and add 5 points to the value, because what we're going to do is compare this value later on to other pupils, and if it's within a range of 5, as you do some testing on the pupil, throughout the pupil, you know, if, let's say we get a value of 40 for intensity, it may range between maybe 38 to 43. So we want to make sure if we find another black pupil that we're not going to determine that's a cataract, that it's just within the normal range. So this is giving us a slight buffer. So we have our data output for intensity comes into our math function, and we automatically add 5 to that, and we create the variable called low. This is the low value that we're going to test against when we look at our other pupils. So we've written that, and as we click on our variable here, we have a read to the right function, so we've written that value of the intensity plus the additional 5, and your range may vary. Then we've created another variable called white. This is the value that's going to count every time we find a white spot in a pupil, which would indicate a cataract. So we've created this variable, and we've set this value to 0 before we are going to utilize that later in a loop. Then we have our robot reversing, moving out, turning back into its original position, turning completely around, and then moving forward. And so all these motor functions are just cut and paste of the original ones, and then changing whether I want to go forward or backward by changing my direction. As we approach the other pupil, this would be the one we're doing our experiment on, I have also put another push sensor. So that way, it's not until we press the sensor we'll begin collecting data. We have a loop here we created. The loop is a 10 count loop, so it'll just go through 10 times. So we're going to randomly check locations of the pupil to see whether there's a cataract, a white spot, or a black spot. So we're going to do this 10 times. As we enter into this loop, I also have another sound played. It's called record. So every time we collect data, there'll be an audio cue that we're collecting data. Here we have the light sensor. Again, is going to now check the pupil of the different eye. And again, we're just looking at the intensity level. And we're storing that in this variable, as a pupil color, or as pupil, and determine the intensity of basically of the experimental pupil. So we end up comparing the pupil to the original control. What we added here are some randomizers. What I want to have is the motor randomly move and take different locations in the eye. So it's going to take 10 random locations. So we have this generator here that goes between 0 and 60, and the 0 to 60 is inputted into the motor function that is holding the light sensor, and it's on the duration. So this will determine how long the motor should be turning, and that will help to change its position. So we've set it between 0 and 60. We also have another randomizer over here, and that value goes between 0 and 1. And what we're going to do with that is compare it to a constant. So I set this constant to a value of 0, and then I have a randomizer that goes between 0 and 1. And then we're going to compare those two values. So the constant comes into the B port, the randomizer comes into the A port, and then our compare function is to see if they're equal to each other. So the randomizer can be 0 or 1, and the constant 0. So sometimes it's going to match with the constant, and sometimes it will not match with the constant. When it matches, we'll get a true result, and it changes the direction of the motor. And if we get a false result, it reverses the motor. So not only are we randomizing the duration, how long the motor turns, but also randomizing whether it's turning clockwise or counterclockwise, giving us a random look into the pupil to gather our data. So next we want to do is compare whether our light sensor is above or below what our control was. So here we have we're going to read our low value that we recorded earlier, and here's our pupil value. We're going to read that, which we just assigned, and we're going to compare those two. So here we have a greater than, and we're comparing is A greater than B. It forms our next loop. What we have here is a logic loop. So if A is greater than B and it's true, we will run through the top of this loop. And if A is less than B, if A is greater than B is false, then runs to the bottom of the loop. So if it's true, what happens? It's actually a white spot on the eye, which is considered a cataract location. So we take our white counter that we initially set at 0. We have an addition here of +1, resulting in a value that will go into a right variable. So we're going to read the variable, add 1, then write it. So it's basically a counter. And then once we're in this loop, there's also another sound cue that says light. And that's kind of indicating that they found a light spot. If this initial comparison is false, it'll travel along the bottom, giving us also another audio indicator. It'll say dark, which means it's similar to the pupil of the control, which was dark. And then it will leave this loop and will continue through this loop 10 times. And every time it goes through the larger loop, it re-rotates the motor, finds a new location, gets the new light value, and then compares the two against our initial control. Once we do that 10 times, we are out of that loop, and we can finish up with first initially just a quick 1 second pause. Then our robot will reverse, move out of its location. Next, it takes the value of the white. So out of the 10 times it counted how many times it had white spots. And we're going to read that value and use another compare math block that's going to compare 5 to a range of values. So we've inputted our value of the count of white, and if we look in our operations, if it found between 5 and 10 white spots, we're going to consider this person a candidate for cataract surgery. And so it goes into another logic loop. In this logic loop, when it's yes, we'll have an indicator on our brick, on our NXT brick, that has an unhappy face. If they are not within the 5 to 10 range, so this becomes false, meaning that it's less than 5, the NXT brick will display a happy face. So they're not a candidate for cataract surgery. And once you've completed that loop, I just have an 8-second wait period, just so I know is at the end, with another audio cue that says attention, to make sure you look at the screen. So the 8-second wait is allow you to visually look at the NXT screen to see if you have a happy face or a sad face. Once the program ends, it clears the screen. I hope that was useful. Thanks for listening.